Our next lesson in Topic 2 is Lesson 2.3, Parallel Lines and Triangle Angle Sums. In this lesson, our learning target is to use the triangle sum and triangle exterior angle theorems. A theorem is something that is proven to be true. Our first is the triangle sum theorem. From Topic 1, we recall the sum of the measures of the interior angles in a triangle is 180 degrees. And we've already worked with that in this topic. Now for the picture on the right, we just have a triangle with capital letters A, B, and C to recognize the three angles in that triangle. Our notation is that the measure of angle A plus the measure of angle B plus the measure of angle C should have a sum of 180 degrees. If you know any two of the three angles, we should be able to just subtract from 180 to get that missing angle. Now the next one's going to be a little different. It says it's the exterior angle measure theorem. The measure of each exterior angle of a triangle is equal to the sum of its two remote interior angles. So that's a little bit trickier. What I want you to do for your diagram is draw a triangle, and it can look even like the one up above, but then extend one of the side lengths. So if I kind of draw it to look like the picture up above, I'm going to take my line and keep going off to the right. I'm going to put a 1 in that right-hand corner on the outside. That's my exterior angle. Now the two remote interior angles are the two angles that angle doesn't touch on the inside. So I'm going to put 2 on the top and 3 over on the left-hand side. Notice the notation. The measure of angle 1 is equal to the sum of the measures of angles 2 and 3. So 1 is exterior on the outside of the triangle. 2 and 3 are called remote interior. Remote means they don't touch the original angle, and interior means they have to be on the inside of the triangle. So far we're not dealing a lot with parallel lines, but these rules have a lot in common with things pertaining to parallel lines. Let's take a look at how a triangle can connect to a straight line. It says what appears to be the relationship between the angle measures of the triangle. Well, if I notice here, I connect the blue to the green, that angle measure. Over on the right, I notice that the blue to the green is that portion on that kind of three-part triangle, or that three-part angle for that straight line. And then I see another angle from red to green that would be different, and that measure is a little bit smaller. But then the big angle up at the top, I'm going to put 3 arcs on that one because it's different than the other two. That represents the angle over here on that left-hand side. Now together, in the triangle, we know that those angles add up to 180, but here's why. If we were to stretch each of those angles out so that they shared the same vertex, our angles would form a straight line. So the thing that we could appear to share for the relationship is that the angles would form a straight line. I'm going to run out of space here. If they were put in a row. Well, maybe say we'll put together in a row. Let's add that in there. If they're put together in a row. And that's how we know that they would add up to 180. Now we'll do a lot of justifying in this class. We've talked about that a lot. In lessons 2.1 and 2.2, we justified why angles or lines are parallel by either a theorem or a converse. In this next one, it says, given two angle measures in a triangle, can you find the measure of the third angle? Explain. Well, we know that we can find that third angle because any three angles, or because the three angles, I should say, in a triangle, doesn't matter which one it is, always have a sum of 180. So if we know any two, we can always take them and subtract from 180 to find the missing value. All right, let's do some algebra. We've got a few problems left. What are the values of x and y? Well, I see x on that right-hand side and y is kind of in the middle. I notice right away that we could get y without doing too much extra work. Together, these two form a straight line, so they create a linear pair. Because of that, y plus 78 degrees would have to equal 180. To get y by itself, we'd subtract 78 to move it over. So even though there were two variables to solve for, the first one is really quick. Y should equal 102 degrees. All right, now let's take a look at the other variable, the variable x. I notice in this picture x is on that right-hand side. And up at the top, t equals 32, but that's not the entire angle for t, that's just this part on that right-hand side. And we recall that little r on that right-hand side is 78. Therefore, if I figure out to get x, if I just use part of the picture and not the whole thing, t at the top, s on the right, and then r on the left, r is 78, and the angle at the top is 32. And if we want to know what x equals, we can apply the triangle sum theorem. X plus 78 plus 32 is equal to 180. Now, if we combine like terms, 78 plus 32 is 110. So then to get x by itself, move that 110 over. And now it's very similar to the other problem. X should equal 70 degrees. And this is the type of work I would be looking for on either your homework or an assessment. Let's now take a look at the exterior angle measure theorem. Our first example, it says, what is the missing angle measure in the triangle? Use that angle to help you find the measure of angle 1. So if we're just looking at the inside of our triangle right here, to find that missing angle on the inside, I'll call that x. We'll just name it a variable. Like our last example, if we just add the two measures together with x, they should equal 180 degrees. Now, 45 plus 75 is 120. And if we want to get x by itself, we need to move 120 to the other side. And x would equal 60. Now, if x is 60, angle 1 should be supplementary to it since they form a straight line. Right there. So to get angle 1, if we add 60 to it, it should be supplementary as well. Now, if we move 60 over, we get the measure of angle 1 is equal to 120. But if you recall, 120 is a number we've already worked with. That's what we got when we added those two angles on the inside. So remember our definition, everybody? The exterior angle is equal to the sum of the two remote interior angles. So you can always add the two that aren't connected to it together to get that outside or exterior measure. Let's see how that works with the next example. What is the measure of angle 2 in this figure? Well, notice on the right-hand side, 109 is on the outside. 51 and 2 are both on the inside. Therefore, using that exterior angle measure theorem, measure of angle 2 plus 51 should equal 109 degrees. Now, what would we do to get angle 2 by itself? This is just algebra again. Let's move that 51 to the other side. And the measure of angle 2 should equal 58 degrees. And that's how you use that theorem. It's really just algebra based. Example 4a, what is the value of x in the figure? Well, now this time x is on the outside and 54 and 57 are on the inside. To figure out that measure, we're just going to apply that exterior angle measure theorem. The sum of the two remote interior angles will always equal the value of the exterior angle. How easy is that? We're just going to add them together. 54 plus 57 would be 111 degrees. And that's what x will equal. We'll throw in a little more challenging algebra, but it shouldn't be any crazier than something like this. Therefore, if you can navigate this, we're going to be in great shape for this lesson. Last but not least, what's the value for x in this figure? Now look at where 100 is. That's on the outside up on top. The 2x minus 3 and the 51 are both on the inside. Therefore, what we should do is add them together and then set them equal to 100. So let's see what that equation looks like. If we take angle L, which is 2x minus 3, plus angle N, which is 51, we should get that exterior angle of 100 degrees. Now be careful on this left-hand side. The negative 3 and the 51 are together, so we're just going to combine like terms. And we end up with 2x plus 48. Setting that equal to 100, now let's start moving things over. If we want to get x by itself, let's move that 48 over by subtracting. And that would give us 2x is equal to 52 degrees, or 52. Divide both sides by 2 to get x by itself, and 52 divided by 2 means x is equal to 26. If x is 26, then that exterior angle theorem would hold true. And that's where we'll end. We'll save this word problem for when we're back together in class.